Okay, guys, so right now we're going to talk about decomposition reactions. So let me get my papers ready. You saw nothing. So decomp reactions for short. Here's the definition. This is when a single reactant is broken down into two or more products. Okay, please note that these reactions usually require a catalyst. Remember, a catalyst is just, a catalyst is just a substance that speeds up a reaction without being used in it. Here's the alphabet soup for a decomp reaction. We have AB together, breaking down with the help of a catalyst to form A plus B. It's the exact opposite of a synthesis reaction. And here's an example. So, steam and oxygen gas are liberated when an aqueous solution of hydrogen peroxide is catalytically decomposed by potassium iodide. A lot is happening here. So, hydrogen peroxide is decomposed. Hydrogen peroxide will be our reactant. Steam and oxygen are liberated, meaning they're released. So those will be our products. So I would write this as my equation. I have hydrogen peroxide breaking down with the help of potassium iodide as the catalyst to form oxygen and water. Remember, steam is just gaseous water. So once I get that, I just have to balance it. So I'm going to add a 2 and a 2. We're good, happy, or ready to go. So that's a basic example. This would be what we consider a binary decomposition. There are two elements. There's no polyatomic ion. So it's binary. It's nothing fancy's happening here. So let's get into the types. We have, like I said, the binary decomposition, and that follows our pattern AB yields A plus B. It's just when a compound breaks down into its elements. Then we have a carbonate decomposition. So this is when a carbonate compound breaks down into a metal oxide and carbon dioxide. So you're going to have your metal with a carbonate. You're going to make a metal oxide, and you're always going to make CO2. So this will be the pattern you would follow if you're trying to decompose a carbonate compound. Our next type is chlorates. So this is when a chlorate compound breaks down into a binary salt, which is just a super fancy way to say our metal with chlorine and then oxygen. So again, you're going to have your metal with chlorate. It will decompose to form your metal with chlorine, and then you're always going to make oxygen. So for my B-level students, this is all you need to know. So at this point in the video, you can shut me off, okay? Just note that you need to remember these patterns because it will really help you when we're trying to solve these problems. Okay, so take really detailed notes, but at this point, you can turn this video off. Moving on. We have bases, and we can decompose them. So remember, a base is anything with hydroxide. So these are going to break down into a metal oxide and water. So we're going to have our metal with our hydroxide. We're going to make our metal oxide, and then we're always going to make water. Easy enough. And then finally, we have our acids. So our acids will break down into the non-metal oxide. Non-metal oxide and water. Okay, so as you can see here, I have an H here because H indicates that it's an acid. Then I have my non-metal with an oxygen because most of the time it's going to be H with a polyatomic ion. We're going to produce our non-metal with oxygen and then water. So that's what we're always going to make when we decompose an acid. So for my A levels, let me try to get everything in here. these are the 5 types of decomposition reactions. You want to take detailed notes on these 5 patterns because this will help you as you're solving for these problems. Okay? So if I were you, I would pause the video so you can take really nice notes.